And again, so yeah, so what I'm going to try to do today is to finish up with the review for this class and pretty much finish up with the material that you would need to know to complete the homework for tonight, which is due tonight. So last time we talked about classifying numbers, right? We talked about natural numbers, and then we've extended them to the integers, and then we extend them to the rationals, and then we talk about the irrational numbers, and then the real numbers include all those numbers. And then we transitioned into understanding how to interpret sets and interval notation and set builder notation and knowing how to graph them, and talked about union and the intersection of sets. So that's one thing that we've spoken on. And now we're going to continue with knowing how to do operations, apply operations upon the different kinds of numbers. In particular, we're going to focus on integers and rational numbers. So we're going to talk about the operations applied to on integers and rational numbers. Okay. Okay. Let's see. So integers, right? The integers are whole numbers that are either positive or negative, and that include uh, 0. So, for example, just little examples here. What would be negative 39 minus 5, for example? It's okay, David. I'm glad you're able to be here. So the question is again, what is negative? Okay, so everybody understands. Okay, good. So negative 44. Good. So when you have the same sign, you just combine 39 and 5 by adding them, and then you just keep the sign, right? Good. So you guys understand that. Okay, good. And what if I do negative 39 minus negative 5? What does this become? Minus 34. Good, because this becomes what? Negative 39 plus 5, right? When you have a negative times a negative, it becomes a negative times negative equals positive. So this becomes a plus 5, and negative 39 plus 5. Uh, well, one way to consider that. So this is where some students may have some trouble. You can consider it in two ways. One way is to, when you have opposite signs, is just to subtract them and choose the bigger, and choose the sign of the bigger number. So for example, in this case, 39 and 5, subtract 39 and 5, and you get 34. And then all you're going to do is include the sign of the quote unquote bigger number. Which one is bigger, 39 or 5? 39 is bigger. And what's the sign associated with 39? It's negative. So we put a negative. That's why it would be negative. That's one way to think about it. Another way to think about it is if you include what, another way I would like to envision it sometimes is using the number line. And you start at negative 39. That's your starting position. And then when you add 5, you move 5 units to the right. So it's essentially you're asking yourself, what number is 5 units to the right of 39? So 39, 38, 37, 36, 35, 34, right? This is 5 units to the right, 5 units to the right. Again, when you move to the right, you're adding. When you move to the left, you're subtracting. That's another way to think about it. So this is negative 38, negative 37, negative 36, negative 35, and finally negative 34. That's why the answer would be negative 34. So that's two ways to think about this kind of problem. Okay. So I'm glad that we're able to, that we understand this for the most part. Um, what if I have something like this, 135 divided by -5? What if I have a positive number divided by a negative number? First of all, if I have a positive divided by a negative number, what is the result? Is it going to be a positive number or a negative number? It's going to be negative, because as long as one number is negative, the result will be negative when you divide or when you multiply. And I think you said correctly, Kailani, you said -27. That's right. Okay. Okay. What else is there? What if I do this? What if I write as 2 multiplied by -26? What would be the result? -52. Okay, good. Okay, so again, this is review. This is stuff that you've seen before, how to add, subtract, multiply, divide integers, whether it be positive, whether they be negative integers, whether they're a combination of positive and negative integers. Okay, great. Now I want to talk about in line with integers, and in particular with multiplication. What happens if you have, for example, what if you have 3 multiplied by 3, multiplied by 3, multiplied by 3? Is there a better way to represent a repeated multiplication of a number? Exponents, very good. Very good. Yes. So if you see, you have 4 3s, right, in product. So one way to create what's called a shorthand notation for repeated multiplication, we use exponents. So we use 3 and we raise it to the 4. So 3 here is my base, and 4 represents what's called the exponent. And again, the exponent tells you the number of times that the 3 appears in the product. So this is the number of times that the base is found in the product. So you're multiplying 3 times 3 times 3 times 3. You see 4 3s when you multiply. So it's exponentiation. Exponent is a way to represent repeated multiplication. So just make a little note of that. Note is that exponents are used as a shorthand notation for repeated multiplication. You can also think of multiplication as a shorthand notation for repeated addition. So if you add 3 plus 3 plus 3 plus 3, you can just say 3 times 4. But if you multiply 3 times 3 times 3 times 3, is 3 to the 4. So, okay, good. Okay, and what if I have something like this now? What if I get -2 to the 4th? What's -2 to the 4th? That's right, Elizabeth. Very good. So you can think of -2 times -2 times -2 times -2, right? And no matter how you dice it or slice it, -2 times -2 is +4. -2 times -2 is +4. You're still multiplying, so it's 16. So -2 to the 4th power will result in a +16. Now, what if I give you, so versus, what if I give you something like this, -2 to the 4? What is this equal to? -16. Okay, so what's the big deal? What's the difference between -2, the one that we had on the left side, and on the right side? Why does it produce two different numbers? The parentheses, guys. So the parentheses is big. It's huge. It's almost everything when we talk about evaluating expressions. Knowing where the parenthesis sign and knowing what is associated to the parenthesis sign will either lead you to the correct answer or just make you lose your way. So -2 to the fourth, this 4 is not associated to the -2. This 4 is associated to the +2, just the 2 itself. That's why, in a way, you can think of it like this. This is 2 to the fourth first, and then you attach that negative at the end. So knowing where the parenthesis sign tells you a lot. And one thing I want to make sure we remember is the order of operations. Does anybody know the order of operations? What is that famous acronym? PEMDAS. That's right. It's PEMDAS. This is the way the world works in mathematics. You have parentheses. That's the first order of business to take care of. Then you have the exponents is the second thing we take care of. And then the multiplication and division is the third and fourth. And you can see that you'll see that you can actually interchange the order of M and D and you can also change the order of A and S, but for now, just keep it like this, division, and we have addition and subtraction. Okay, so this is the first thing we do. And then we go to the last thing we do. So that's also very important to keep in mind. Okay, so let's see how we can evaluate certain expressions understanding this. So if I have something like this, 5 minus 8 minus 12 plus 3, what is this equal to? -12. Okay, so what do we do first? We add. Okay, so what do we add? We add -12 plus 3, right? What's -12 plus 3? -9. And then what do we do after this? Can you solve it from left to right? Yeah. So that's what I was gonna say. Sometimes you can just interchange the addition and subtraction. We could have interchanged it, meaning that we could have said, hey, let's subtract first. 5 minus 8, that's -3. Minus 12 plus 3, then you said -3 minus 12 is -15, but plus 3, this gives you -12. Or we could have just been more strict to the PEMDAS rule and just said, hey, let's add first, because that's what it tells me to do first. It tells me to add first. So -12 plus 3, we could do this as well. This is -9. And then all we have is subtraction. So then just subtract. -5 minus 8, that gives me -3 minus 9. That gives me -12. So the answer is -12. When you say, Jalen, when you mean common numbers, what do you mean by common numbers? What are common numbers that you speak of? With the same sign? Yeah, you can do that as well. You can do that if you'd like, but eventually you'd have to combine the positive and negative numbers, right? At the end, eventually, somehow. You're gonna have to connect it. Like 5 minus 8, you're doing 5 positive minus 8 negative. So you can, but not it's not necessary. Okay, so we got that down. Um, what about what about this? What about 24 divided by 2 multiplied by 6? 36? Uh-huh. See, so so this is where things get a little confusing, right? Some people say 2, other people say 72. So then who's right and who's wrong? This is when things do get confusing. Um, because some people, yeah, the problem is because there is no parentheses. So some people may be like, okay, I have to multiply first, right? I have to multiply first. So then they say 2 times 6 because I have to multiply first. That's what PEMDAS tells me. And that's 12. And then that's how you get to 2. But the problem with that is that this 2 is dividing the 24. So so you hmm, in the yeah, Sierra, that's one way to think about it. If you don't have parentheses, you go from left to right. That's one way to think about it. So in a way, you can start to see that PEMDAS, right? You have to be careful with PEMDAS. You can't be so like just, oh, multiplication, just multiply first. You have to take things a little bit carefully. And there's like a lot of these different problems that people make, like to show that there's two different answers. Some people get 2, for example, in this case, some people get 72. And then the question is, why do people get 2 different answers if it's the same uh, question? And inherently, this is my opinion, inherently, this problem shouldn't be given this way. It's just, uh, yeah, it shouldn't be given this way. It should be more explicit. Um, Now, I'll show you how I interpret this, okay? This is the way I interpret it. In a sense, I am interpreting this as these having parentheses. So when you say 24 divided by 2, isn't it okay for you to say 24 over 2? And then you multiply the 6. So that's one way you could have interpreted this. And then this becomes 12 multiplied by 6, which is 72. That's one way to interpret it. Another way is, I think, who said that? I think someone said that if it has no parentheses, just go from left to right. Yeah, Sierra said that, right? If there's no parentheses, aren't you supposed to go to left to right? But then the question I'm going to ask to you, Sierra, is who told you, or how do you know you go from left to right? Why don't you go from right to left? Like, who, how does one say, yeah, left to right instead of right to left? Like then you start, you know what I mean? We read from left to right, yeah, but there's other people that read from right to left. Like there's other languages that are out there that we read from right to left. So then we tell them, no, you guys read from right to left, and we read from left to right. So see that's where things get a little bit ambiguous. And inherently, this is an ambiguous example. It is because you're right. We read from left to right, so it's natural for us to be, oh, it's 24 divided by 2 first, not 6 times 2. You understand? So it would be better. It would be better as an example if I either say this 24 divided by 2 parentheses times 6. That's going to be 12 times 6, which is 72, versus 24 divided by 2 times 6, which would be 24 divided by 12, which is 2. So what I'm going to say is just, I'm going to give you problems I'm going to try that are not disambiguous. I'm going to give you problems that they give you an exact way to do it. So there is an ambiguity here. But these things do happen. But it's cool to think about it, right? Okay. For example, something like this. This is more clear as to what we're supposed to do. This should be more clear. So the first thing we do is what? 8 minus 15, that's right. So 8 minus 15 would be what? -7. And then the next thing we have to do is multiplication. 4 times -7 becomes what? -28. And then what we have to do is combine the numbers here, -9 and -28. And the result will be, pardon me, negative what? -37. Okay, good. So see, that one was straightforward because there's no ambiguity there. We know exactly where to go from here. Okay, let's see something like this. So if I got 27 divided by -3 plus 5 multiplied by 2 minus 8 squared. What if I have something like this? What should I do first? What could I do first? 2 minus 8, okay, parentheses, that's right. These are my parentheses here. So this will be what? What's 2 minus 8? -6. So we got 27 divided by -3 plus 5 multiplied by -6 squared. What's the next thing I do? I need to do what? Square. So what's -6 squared? Right, it's the -6 that's being squared. So you get +36. It's +36. And then after I square the 36, square the 6, -6, what should I do next? So this is the parentheses, this is the exponents, and then this is going to be the division, right? We got to divide after. And then 27 divided by -3 is -9. Well, actually, we can multiply too. We can also multiply this. And 5 times 36 becomes, what does 5 times 36 become? 180. Good. Do you see how it doesn't matter if we did division first and then multiplication? Do you see how it's not going to affect it? Even if I were to do this first and then I do this, do you see how it's almost, it doesn't matter what the order would be? I will still get the result, -9 plus 180, and the result would be 171. Okay. So any questions about this so far? Straightforward. I hope you guys are all okay with this. Okay, I'm gonna give you one that looks similar to the one we did with the ambiguity, right? I'm just gonna tell you that according to the answer that's provided for this example, they prefer the 72 over the 2. So whenever you have situations that look like this, we are going to go from left to right when there's no parentheses. Okay, so let me give you one like that. Let's see, 63 divided by 2 minus 5 squared times 16 minus 4 times 8 minus 15. So what's the first thing we do? 2 minus 5, that's right, parentheses. So 2 minus 5 is -3. But then that -3, what's associated with that -3? The squaring. So what's -3 squared? Parentheses, of course, -3. +9. So I'm going to replace this as 63 divided by 9 times 16 minus 4 times 8 minus 15. So now, what do we do here? Do we divide 63 by 9 first or multiply 9 by 16? There's no parentheses. So what's the first thing we should do? We divide, right? So Christopher, we divide, not multiply. So we do 63 divided by 9, even though PEMDAS says to multiply first, but we just looked at an example where we have to, because there's no parentheses, we do whatever is first on the left. So 63 divided by 9 is 7. 7 times 16 minus 4 times 8 minus 15. Now, what is 7 times 16? Is 112. Okay, so 112 minus what? What's the next thing we do? -4 times 8 is -32 and minus 15. Okay, so then we can just go about our merry way, right? 112 minus 32 is? So what's 112 minus 32? It's 80, right? And 80 minus 15 is 65. So the answer is 65. Okay. Okay, so good. Good. So now we're going to kind of head into the arena of rational numbers. And again, rational numbers are just ratios of integers. So we're building upon integers, and then we're going to build upon integers using rational numbers. Now, what if I get something like this? 14 minus 22 divided by 2 squared, subtracted from 9 minus 21 over 6, multiplied by 3 squared. So now that symbol here represents a rational number, the fraction. So what should we do first? Right. So we should look at the parentheses first, everything with parentheses. And then in the parentheses, we can simplify. That's right, Joey. So we can simplify within the parentheses. So the first thing we to simplify would be the 9 minus 21. So that should be the first thing on our radar, 9 minus 21. So this is going to be, and if in a way, so this is where it can get a little tricky. When you have a fraction like this, right? In a way, you can break this up into numerator divided by denominator. So without it being there really are parentheses around the 14 minus 22. So when you have fractions like this, there really is a parentheses around, even though it's not written. So you can do 14 minus 22 also. So 14 minus 22 is negative 8. And I'm dividing that by 2 squared minus parentheses 9 minus 21 would be -12 over 6. multiply by 3 squared. Now, we can continue with the simplification within the parentheses, and negative 12 divided by 6 is negative 2. And then again, you see how we could have done the 14 minus 12, 22 afterwards, but we just did it before at first. So we got negative 8, and then the square, what do we do after we do the parentheses? We take care of the exponents. And what's going to be 2 squared? Positive 4. And the 3 squared becomes, I'll just change that right now, it becomes a 9. And then we can multiply here first, right? We can multiply this, and then we can divide this. And when we do divide, we get negative 2. There's a minus, and this is going to be negative 2 times 9 is negative 18. But whenever we have a minus a negative number, this becomes negative 2 plus 18, right? As we saw in the beginning, a negative 2 plus 18 would be a positive 16. Right? Good. So any questions about this kind of problem? Okay, awesome. All right, so we're heading into the world of rational numbers. We're gonna continue on from integers, dealing with integers to, as we saw with this example, with rational numbers. But it just so happens that these rational numbers were all whole numbers at the end, right? They're just integers themselves. So now we're going to be dealing with rational numbers that are not integers. So we're gonna talk about adding, subtracting, and multiplying rational numbers. So let me give you an example first. So what if I have something like this, 7 over 8, and I'm adding negative 11 over 12. So over my experience, a lot of students, they don't like to deal with fractions, but dealing with fractions makes life easy if you know how to deal with them. So when we add fractions, right, when we add them, what is the prerequisite? What is the requirement in order to add them? What must be true? Right. We must have the same denominator, or in other words, the common denominator. You cannot add two fractions if you have different denominators. That does not make any sense. You can't make sense of saying a third plus a fifth, and you have to make them of some kind the same so you can compare them. Okay, so if that's the case, then what are we looking for? We're looking for what's called the LCD. Very good, Kalani. The LCD, also known as the least common denominator. So I want to find the LCD among what? Among 8 and 12. So I want to find the least common denominator, and the least common denominator is associated with what's called the least common multiple. So it's the least common multiple. So when you think of LCD, you're talking about the least common multiple of the denominators. So that's really what you're looking for. So what's the least common multiple between 8 and 12? Right. So many people said 24. Very good. Now, how do you find the least common multiple? In general, what's the idea? How do you guys know that it was 24? Why not 48? So Christopher, GCF is not the same as the LCD. That's another thing people tend to have confusion with. They think it's the same. It's not the same. They're two different things. One is the factors that's in common. The other one is the multiples that are in common. So you need to know the difference between the multiple of a number and the factor of a number. A factor is just a number that makes up the number. The multiples are the numbers that are produced by the number. You just multiply 8 and 12, but if you multiply 8 and 12, you don't get 24. That's my question. How do you know that 24 is the right one? Not by each. Okay, so right. That's right. That's right. That's right. So you look at the multiples of 8. That's what you do. You find the multiples of 8, right? And you list them out, right? You list them. So the first multiple of 8 is just itself, 8, then 16, then 24, right? And then so on and so forth, right? 32, then 40, then 48, and then this goes on forever. The multiples go on forever. That's only multiples of 8. What are the multiples of 12? The multiples of 12 are 12, 24, 36, 48, 60, right? And then you start to see, hey, they're common ones. They're common ones. The 24 is common. The 48 is common, and so on and so forth, right? But you want to know which is the least common, and the least common is 24. That's the smallest one. That's going to be the least common multiple. So that's why we say it's 24. So my LCD is 24. Great. So now once I know that my LCD is 24, what do I do with this information? Why is this helpful now? So once I establish the LCD, how do I use it now? Yeah, you multiply the top and the bottom by the appropriate number that gives you the LCD in the denominator. So you realize, hey, 8. I want to make 8 into a 24. So I must multiply the 8 by 24. I must multiply the 7 by the 3. I must multiply 8 by 3, and then correspondingly I multiply 7 by 3. And then here I'm going to multiply this by a 2, right? So then the result becomes 21 over 24. This becomes plus negative 22 over 24, correct? So now this is good because now I have the same denominator, and then I can compare these two numbers. Now I can combine them. Right. So the answer at the end will be, because now that I have the same denominator, I can just set them as into the same denominator and just say 22 plus negative, you can think of it, right? Negative, pardon me, not 22, 21. This is 21 plus negative 22, which is the same thing as saying 21 minus 22 over 24, which is the same thing as just saying negative 1 over 24. So the answer would be negative 1 over 24. Okay, so that's how we add fractions. We need to find the LCD, and the least common denominator or the least common multiple is found by finding the multiples of each denominator and seeing which one is the smallest common one. And then we appropriately multiply the numerator and denominator by the factor that gives us the LCD. And then we can combine the numerators and keep the denominator the same, and then you get your final answer. Okay. Okay, so that's combining rationals like that. And how about if we get something like this? 5/8 multiplied by a negative 18 over 25. So how do we, pardon me, how do we multiply? How do we multiply fractions? Right. So in multiplication of fractions or rational numbers, it's a little bit simpler than adding or subtracting fractions. When you add or subtract fractions, you must. So let me write that. Yeah, must, right? This is a must. You must have the same common denominator. Whereas when you multiply fractions, you don't need to. You just multiply across. Multiply across. So if you multiply across, right, what do you get? You get 5 times 18 and then 8 times 25. What's 8 times 25? 200. And then what's 5 times 18? It's 90, right? Negative 90. And then you can simplify negative 90 over 200. So what goes into negative 90 and 200? Well, uh, you can see that they both have a factor of 10. So you can divide both numbers by 10, for example. And then you're left with negative 9 over 20. So the answer is negative 9 over 20, as some of you has said. And somebody brought up an interesting point. So Tyler said cross multiply. So you can't cross multiply. You don't cross multiply. But what you meant to say is the next thing you said, which is cross simplify. Now that is true. So you're not going to multiply 5 and 25. No. You're not going to multiply 8 and negative 18. That's when you have an equal sign in between and you have a proportion. We don't have that. We're just multiplying two fractions. But what you should notice, and some of you noticed, was that, wait a minute. So one way of doing it, guys, multiplying is just multiplying across and then you simplify afterwards, right? Or you can simplify first. Yeah, cross simplification is not really like a technical term, but I understand what you mean. You simplify across, like diagonally. Diagonal simplification. Yeah, there is no, I don't think there's like a standard way of saying it, but we understand what you mean. Uh, Now, the reason why we can do this is due to the fact that multiplication is what's called commutative, meaning that I can interchange the order of the numbers. And there's another thing that you can also take advantage of is that these numbers can be broken down into factors. So if you notice, this is really 5 over 8, right? Times negative 18 over 5 times 5. And if you want to break it down even further, you can say this is really 5 times 4 times 2 multiplied by negative 9 times 2 over 5 times 5. You can break down the numbers into its factors. And then because of that, and because of the fact that I can interchange the order of multiplication, right? 5 times 5 or 4 times 2 is the same thing as 2 times 4. I can do so in such a way that I could just say, hey, there's a 5 down here and there's a 5 up here. I can cancel them out because they cancel each other out. And then the 2's here also cancel. So when you cancel, they become a 1, right? And so what's left on top? 1 times negative 9 times 1 becomes negative 9. 4 times 1 times 1 times 5 becomes 20. So if you can, I would suggest simplify diagonally. Even simplify vertically. There might be situations where you can simplify vertically first, cancel out vertically. But if you can't, if you notice, there might be numbers that are in common as factors. And if you do have common factors, such as these numbers here, you can simplify first and then multiply afterwards. Does that make sense? I'll give you another example of this, but this time it's not going to be division. I mean, it's not going to be multiplication, it's going to be division. So this is a division example. So does anybody know how we divide fractions? Yeah. So what we do is something called keep, change, flip. Keep, change, flip. KCF, not KFC, but KCF. So whenever we divide, we keep the first. We change from division to multiplication, so you can use the dot symbol there. And then we flip 12 over 25, and this is a negative. Now, what do you guys notice? Sure, we can multiply 5 and 12 and then 6 times 25 and then simplify afterwards, or do what? Is there a common factor between the diagonal numbers? So 5 and 25, but we just saw that, right? If I divide 5 by 5 and 25 by 5, I'm left with 5. And how about the 6 and the 12? Well, you can divide the 6 by 6 and you get 1, and divide the 12 by 6 and you get a 2. So then what's my final answer? It's positive 6 over 5. Well, no, it's positive 2 over 5. Right? Because the negative cancel, it becomes positive. And then, right. Yeah, there's a negative. I don't know if you see it. So it's negative 1 multiplied by negative 2/5, which becomes a positive 2/5. Okay? So we're understanding how to multiply fractions, how to divide fractions, how to add fractions, subtract fractions. And we talked about PEMDAS. So a lot of times, guys, all these things, right, they build upon one another. So let's see how we do something like this. Let's see if I combine this whole PEMDAS stuff with adding and dividing. So I got negative 3/4. If I square it and I divide this by 1/2 minus 2/3, parentheses, plus 7 over 16. Now I want to know what this equals. You see how things start to like get a little bit more complex. We're just combining everything that we've done so far. So what do we do here? Can we still distribute the, okay, so be careful with that. We're not distributing exponents. We don't distribute exponents. Right. So either we do this guy first, but let's just stick with the PEMDAS rule for now. So we have these parentheses. This negative 3/4 is just saying that we're putting parentheses around the whole fraction. So we can't really simplify this any further within the parentheses, but we can definitely simplify this further, right? So the p here. So let's take care of the parentheses first. So we're going to just look at 1/2 minus 2/3. So in this scenario here, we're trying to subtract two fractions. In order to subtract two fractions, what must be the case? They must have the same what? LCD? Okay, and then what would be the LCD between 2 and 3? In this case, it's 6. Pretty straightforward. And then if it's 6, how do I use that to make the denominators the same? What must I multiply 1/2 by? I must multiply 1/2 both by 3, right? 3 over 3. And then multiply this by 2 over 2, right? And I'm left with 3 over 6 minus 4 over 6, which is negative 1 over 6. So the inside parentheses expression here is negative 1 over 6. I'm going to rewrite everything. 3/4 squared divided by negative 1/6 plus 7 over 16. Okay. So that's the first thing. Now what do we do? After we took care of the parentheses, what do we do now? And Emil, I think you might be right. The exponent's right. So then what is negative 3 over 4 squared? How do we deal with this exponent guy here? How do we deal with that? What is negative 3/4 squared? Right. Negative 3/4 squared really is negative 3/4 multiplied by negative 3/4. This becomes negative 3 times negative 3 is positive 9 over 16. So then this is really going to be 9 over 16 divided by negative 1/6 plus 7 over 16. And I think that's what, who said that? Jalen, right? You just said distribute the square root, the squaring of 2. Again, it's not distributing, but I know what you mean. You mean to say that this is negative 3 squared over 4 squared. That's what you meant. You're taking the squaring and doing it to each one. And then what do we do after that? Yeah, a lot of people don't like fractions, but I'm telling you, the more comfortable you become with them, the easier your life will be. I'm just saying. It's better than decimals. Let me just say that. We divide, right? And so when we divide, what do we do? How do we divide? What do we apply? Keep, change, flip. So when we keep 9 over 16, we change division to multiplication, then we flip. Negative 1 over 6 is negative 6 over 1. And then we have to add by 7 over 16, right? Remember, when we multiply, we can just multiply across. Multiply this across and you get what? You get negative 63, 19, no, pardon me, negative 54 over 16 plus 7 over 16. Now you may have asked me, hey, how come you didn't cancel out the common factor between 6 and 16? The reason why I didn't was because I'm adding at the end, right? So that means that I must have the same denominators, and these have the same denominators. So that's why I didn't cancel anything out. And because they have the same denominators, now I can combine. What's negative 54 plus 7? I can combine now. This is negative 54 plus 7, all over 16. And that will equal negative 44 over 16. Oh, 47, pardon me, right? Pardon me. You're right, Valentine. It's 47. Okay. So this one here, this one definitely packed the punch because you have to take care of division, subtraction of fractions, division of fractions, squaring of fractions, and adding of fractions all at once. Okay. So yes, Emil, you got that correct. Very good. Very good. Okay. So that's pretty straightforward in that regard. Okay, so now what if I give you something like this? 2/3 minus 3/4 all over 3/10 minus 1/5 divided by, no, added by 2/3 squared. So one way to interpret this whole thing here, one way to interpret it, this can also be interpreted as you can also interpret this as 2/3 minus 3/4 parentheses divided by 3/10 minus 1/5. You can also interpret it this way. So whenever you have what's called a fractions within a bigger fraction, that's called a complex or called a compound fraction. So this is an example of a quote unquote complex or compound fraction. So that's when you have fractions within fractions. So again, one way to interpret this is to take the first numerator of fractions, treat that as one thing, and divide that by the denominator of fractions. So why don't we take care of that first? Why don't we take care of this guy first? I'm gonna put this as a 1 and take care of this guy second. So the first thing, 2/3 minus 3/4. How can I break this down? Or how can I subtract these two fractions? I need to find what is called the LCD. What's the LCD between 3 and 4? 12. It's 12, Jalen. Because, yeah, the smallest multiple. 24 is a common multiple. It's just not the smallest. So 12 is the smallest. Since 12 is the smallest, I can multiply this by 4, multiply this by 3, and I'm left with 8 over 12 minus 9 over 12. This equals negative 1 over 12. Okay? So that's the first one there. Now, what's the second one? The second one is 3/10 minus 3/10 minus a fifth. Isn't it all the same once you simplify it? What do you mean by all the same? What's all the same? 24. Oh, I see what you mean. Right. I never said that you can't use 24. I'm just saying that's not the least common denominator. It's just, of course, these numbers are small, right? So 24, 12, it's not a big difference. But when we talk about like bigger numbers, then you care about finding the smallest. You wouldn't want to find bigger than the LCD. But yeah, if you make both of them the same 24, again, the goal is what? Making the same denominator. So if you can make the same denominator, by all means. But it's just in practice, you would always want to be the smallest common number. And then someone said 10. That's right. The LCD between 5 and 10 is exactly 10. 5 multiples of 5, multiples of 10, the smallest one is 10. So then you don't have to change the 3 over 10. You don't. You only have to take care of the 1/5. And you can do that by multiplying the top and the bottom by 2. And I'm left with 3/10 minus 2/10, which equals 1/10. Okay, so then I could rewrite this as the top portion here would be negative 1/12, and I'm dividing that by 1/10, and I'm adding that by 2/3 squared. And again, I can interpret this as negative 1/12 divided by 1/10 plus 2/3 squared. Does everybody follow me? So all I did was I replaced this guy with negative 1/12. I replaced this guy with the 1/10, but I can interpret this division of fractions as one fraction being divided by the fraction below. But then in order to divide fractions, what must we do? Actually, after we do that, right? Can we just look at the exponent next? So we can separate these two things into different sequence of steps. So let me just rewrite this over here. Let me just make a note that I'm going here. And this becomes plus 2/3 squared. So when we divide or when we exponentiate, what's 2/3 squared? If you take 2/3 and you square it, you get 4/9. Very good. And then when we take negative 1/12 and divide it by 1/10, what does that become? That's right. So you multiply by the reciprocal. So this is negative 12 times 10/1, which results in having it as negative 10/12 plus 4/9. But hopefully you see that you could have canceled it. You could have canceled something before, right? You could have canceled the 2. This becomes a 5 and this becomes a 6. And then you can recognize that here as well. So this becomes negative 5/6 plus 4/9. And again, we want to make our numbers as small as possible, so we don't have to worry about the calculation as much. And then what's the LCD between 6 and 9? 18, very good. 18 is the common multiple of 6 and 9. So I need to multiply this by 2/2. I need to multiply this by 3/3. And I get negative 15/18 plus 8/18. And this results in negative 15 plus 8 becomes negative 7/18. Right? So our huge fraction that we had originally really just simplified to one single fraction, negative 7/18. Okay? Do we feel much better with fractions now? I hope a little bit more. Okay, so that's how we deal with operations on integers and rational numbers. So now we're gonna just try to talk a bit more about solving equations. In particular, solving they call it first degree equations. So again, things that I believe most of you have done already, right? So for example, if you get something like negative 12 equals x minus 3, I want to solve for x, right? So how do I solve for x? You isolate it. How do we isolate it? What does that entail? Move negative 3. So how do we move a negative 3? We have to add, right? So we add 3 on both sides. And then I get what? I get negative 9 equals x, or in other words, x equals negative 9. So that's how we do it, right? We want to get x by itself. We have to apply x is negative 9. What if I get something like 8x equals 4, for example? Right? How do I get x by itself? Solve for x. Yeah, we have to divide both sides by 8, right? So I get x is equal to 4/8, but 4/8 reduces to a half. So x equals 1/2. Okay. Pretty straightforward, right? So far. What if I get something like this? X plus 2/3 equals 5/6. I want to get x alone, don't I? So I have to get rid of the what on the left side of the equation.
X equals 1/6, I think. Something like that.
But how did you get that?
5/6 minus 2/3.
Right. So you subtract it by 2/3 on both sides, and then
Yeah.
and then
And then the answer is what X equals.
no, I know, but how did you know what to do after that? Like, remember, this results into what?
The
Two frac
difference.
two fractions. And in order to subtract two fractions, you must have the same
Denominator.
denominator. And to do
Right.
that, you need to find the LCD between the denominators, which in this case would be 6. 5, 6 already has the LCD, so I don't have to touch it. But the 2/3 I need to make into the same denominator as 6, so multiply on both sides, the top and bottom, by 2, and I get 5, 6 minus 4, 6, that equals 1, 6. So that's why it's 1, 6. You see that? So good. So see, now we're mixing up our skill set. We've talked about integers, then we're building up that upon rational numbers, fractions, and then we're using that to solve these first order equations. Okay, so what if I get something like this? 3/5 y equals 12. How do I get y? You can multiply, but what do we multiply by? When we have a fraction in front of the variable, I want to get rid of that, right? Yeah, I multiply by the reciprocal, right? That's what we do. We multiply by 5/3. And we multiply both sides by 5/3. So this step here, we multiply both sides by reciprocal of the fraction in front of variable. So you don't cross multiply here, not as, no, we could actually, but we're not going to. We multiply both sides by the reciprocal of the fraction in front of the variable, because when you multiply by the reciprocal, it becomes a 1. 3/5 times 5/3 becomes 15/15, which is 1. That's the reason why. So this here is equal to 1. So you're just left with 1y. And then we multiply 12/1 times 5/3. In this case, the 3 goes into 12 4 times. So 4 times 5 is 20. So that's how we get y equals 20. Okay. Okay. Now, what if I have something a little bit more involved, such as this one here? Negative 3x minus 2 times 4 plus 5x equals 14 minus 3 parentheses 2x minus 3. What if I have something like this? I still want to solve for x, right? I still want to isolate x. So I want to isolate x. But in order to do so, I need to get rid of all these parentheses that I have all around. And to do so, I must distribute everything as much as I can, right? Yeah, so we're distributing now to get rid of the parentheses. So then this becomes negative 3x minus 8 minus 10x. This equals 14 minus 6x plus 9. So all I did was distribute. Now, once I have this, then I can do what? I can do what's called combining like terms, right? We add the like terms. So everything that has the same kind, anything of the same kind, we combine. Negative 3x minus 10x is a total of negative 13x minus 8. This equals 14 plus 9 is 23 minus 6x. And then now the problem is I have two x's on two sides of the equation. I want them all on the same side and everything that's not an x on the other side. So I must add the 6x on both sides. So this becomes negative 7x minus 8 equals 23. But I want to solve for x, so I must add the 8 on both sides. This becomes negative 7x equals, what is this, 31? And then I must divide by a negative 7 on both sides. And I got that the x value is 31 over negative 7. Okay? Does that make sense? Okay. And the last thing that I want to talk about. So we talked about solving equations, first order, of course, is solving literal equations. And these are the equations that that have variables in them. So these are equations where the answer where the solution to the variable is in terms of the other variables. So I'll give you an example of what I mean. So if I give you the example of A equals P plus PRT, and I want to solve for R. In other words, I want to isolate, right? I want to isolate R. So I want to get R by itself. So what's the first thing I should do? So in a way, you treat the rest of these guys as numbers. So if like this was a 5, this was a 3, this is a 2, this is a 7. How to get R by itself? What's the first thing I would do? I would subtract that P on both sides. I would subtract this P first. But I'm treating it as if it were a number. So this is A minus P, whatever that means. And now look what I have next to the P. I have next to the R, I have a P and a T. But they're all what? Connected by multiplication. So then how do I undo the multiplication? Right, I need to divide, and I need to divide both sides by the P and by the T. So the P's cancel, the T's cancel. So what am I left with? R on one side, and the rest is A minus P all over PT. So that's how you solve literal equations. It's the same thing as solving, the steps are the same as solving these regular equations just when you have one variable, except that now we have more than one variable, and we're looking for one variable in terms of the other variables. The steps are the same, it's just that now we're keeping the expression as such. We can't take A and subtract P and make it into a new thing. We just leave it as A minus P. Righty?